Good everyone, my name is Graphics. In this video, we want to solve a problem involving flow dynamic or say dynamic of flow. We will be applying the continuity equation for us to find the discharge, or we should find the velocity of flow. Now, and the question goes like this. It says water flowing through a pipe of 100 millimeter diameter with average velocity 10 meter per second. Determine the rate of discharge of water in liter per second. Also determine the velocity of water at the end of the pipe if the diameter of the pipe is gradually changed to 200 millimeter. Now the first thing you do here is to write out your parameters, right? Now with the question, it says we have a pipe. Let's say this is our pipe. Now the initial position of the pipe, let me say at section 1, the diameter is given to be 100 millimeter, right? And the velocity at that section is given to be 10 meter per second. Now the question now says that it gradually increases. Now look at what's happening to the pipe. The pipe gradually increases to a diameter of what? 200 millimeter, right? And the velocity, we don't know the velocity. That's why we're told to calculate for it. So I'm using a question mark there, right? So the diameter there is 200. So when you convert it to meter, it will be 200 divided by 1000, and we have a 0.2 meter. Similarly, the diameter 1 of the section 1, the inlet is given to be 0.1 meter, right? So we have these two sections, the inlet and the outlet. So water will flow in when the diameter is smaller, then flow out when the diameter is bigger. Now we're told to look for the velocity, V2, and the discharge also. So what you do here is that we'll look for the area of both sections since diameter is given. So the area of the section 1 here will give us pi d square all over 4, pi d1 square over 4. Now what is the d there? The d there is 0.1. Then if I multiply 0.1 square by pi and divide it by 4, I'm going to be having 0.07855. That's what I'll be having, right? I'll be having 0.007855. That's what I'll be having there. Similarly, if I do the same thing for A2, having pi d2 square over 4, I will be having the pi multiplied by the d there is 0.2 square all over 4. I'll be having A2 to be 0.03142 meter square. So this is what we have here for our parameters. Now recall, we know that my Q1, the discharge at the inlet, let's call it Q1, is equals to the discharge at the outlet here. Let's say it is what? Q2. Recall, Q is equals to what? Area times velocity, right? So that means A1 V1 is equals to what? A2 V2. Is that again? Now let's see for Q1, the discharge at section 1 is giving us area times velocity at that section. So what is the area 1 at that section? We have 0.007855 times the velocity, that is 10. So we now have the discharge at that section to be 0.07855 meter cube per second, right? Now if you put it in liter, mean that you multiply it by 1000. So you multiply it by 1000, you're going to be having 78.55 liter per second. Is that okay now? Now the next thing is we've gotten the discharge at section 1. Now at section 2, to get the discharge here, recall Q2 is equals to what? A2 is equals to A2V2, right? So if I calculate for the velocity first, the V2 there will now be equals to what? Q2 over A2. Now what is the Q2 calculated for? That is 0.07855 divided by the A2, that is the area at the section 2, that's giving us 0.03142. So we now have the velocity at that section to be, that is V2 should be giving us 0.25 meter per second. So that's velocity. So with this, we can easily substitute it into the equation above that says Q2 is equals to A2V2. Now we're looking for our Q2 discharge at what? At that section. So Q2 there will now be equals to what? A2V2. What is A2? A2 is giving us 0.03142 multiplied by the V2, which calculated for now will give us 0.25, right? Now the Q2 now will now give us, when you multiply both of them, you'll be having 0.00785 meter cube per seconds. Converting it to liter means you multiply by 1000, we're going to be having 7.86 liter per seconds, right? So that's the discharge. So the discharge at section 2 is 7.86 liter per seconds, and the discharge at section 1 is giving us what? 78.56 liter per seconds, right? So this is what we have. If you found this video helpful, please don't forget to subscribe, like, and also share the video. Thanks for watching.